I had a student ask about this problem. This is number 2 in the 10.3, 10.4 homework. It follows people from adolescence to adulthood and actually looks at obesity, whether you're dating, cohabitating, or married. And they want to know that the relationship are associated. So this is a test of association. And just a reminder, if I'm doing a test where I'm seeing if one distribution meets a proposed distribution, I'm going to use the chi-square test, the goodness of fit test, and then chi-square test. If I'm testing an association, I'm going to go right to tables, contingency, and then use the chi-square test from there. It does make a difference whether we're doing a test of association or a test about a distribution. So let's open this in StatCrunch. And I'm going to change this title to weight because one of my categorical variables is weight and the other one is dating status or relationship status. So my null hypothesis will be that they are not associated or that they're independent versus that they are associated. That never changes when I'm talking about association. We choose the chi-square test of independence because the data were from one random sample in which a piece were classified 2 different ways. It says the smallest expected count is. This is so I can check my conditions, and one of my conditions is large sample. I'm going to go ahead and go to Stat, Tables, Contingency with Summary because I have my data summarized for me in this table. The columns that I'm interested in are the dating, cohabitating, and married. That's my one variable, which is relationship status. My row variable is weight because each of my rows, if you look here, I have a row of obese and a row of not obese. That deals with weight. I'm also going to click expected count here because it will go ahead and give me this expected count that I'm looking for. And I hit compute. So the smallest expected count, when I look, notice the expected count here is in parentheses. So I have 105.58 as my smallest expected count. Sorry, that's my phone ringing in the background, which is certainly more than 5. So that meets my large sample criteria. My level of significance, they've given me up here. It says using a significance level of 0.05, so that's my alpha value. That's what I'm going to compare P to make my decision. I need the chi-square test statistic, which should be up here. Let's see. My chi-square test statistic is going to be 33.44. I get that right here. And then it wants my p-value, and my p-value is 0. It's so small, it's less than 4 decimal places, less than 0.0001. So if I round to 3 places, that's going to be 0. That's so small, it really doesn't depend what my alpha is. That will be smaller than alpha, so I will reject the null hypothesis. If I reject the null hypothesis, I'm rejecting that they're independent. I'm rejecting that they're not associated. So there's evidence that they are associated. I reject the H naught, and then this statement is about my alternative hypothesis. I can conclude that they are associated. Can I conclude from these data that living with someone is making some people obese and that marrying is making people even more obese? Can we conclude that obesity affects relationship status? It just says these people were categorized as to whether they were obese. It doesn't say that this was some kind of randomized experiment. It looks like I'm just observing it. So it doesn't look like I'm able to say that. This is an observational study. No, although a relationship is evident, this is an observational study and cannot be used to prove causality. Then it asked me to find and compare the percentage of, so for that I would just take the percentages and divide them out. I'll let you try that. If you still have more questions about this problem, please let me know, or other problems this week.